superposition principle in respect of Coulomb's law. That means the net force on a charge due to a number of point charges. Superposition principle. That means force on a charge due to a number of point charges. Means here it is Q1, Q2, Q3, Q4, Q5 and so on. So we have to find the force on charge 1 due to these number of charges Qn. Then how will find out that? That is equal to force on 1 will be equal to force on 1 due to second charge plus force on due to third charge plus force on 1 due to fourth charge, and likewise this will be force on 1 due to nth charge. So this will be the F total, F1 total. So according to Coulomb's law we know that this will be the force K, Q1, Q2, R2 to 1 divided by R21 mod Q. Then F13 will be equals to K, Q1, Q3, R3 to 1 upon R31 mod Q. Similarly, force on 1 due to 4 charge, that will be K, Q1, Q4, and then R4 to 1 because it will direct it to this side. And likewise upon this, so this force on 1 due to nth point charge will be K, Q1, Qn, and Rn1, K, Q1, Qn, Rn1 upon mod of the vector Rn1Q. So we can write it K, Q1, Q2, R12 is tip minus tail, R1 minus R2 upon R1 minus R2 vector Q. Similarly, K, Q1, Q3 will be and R1 minus R3. R31 is tip minus tail upon R1 minus R3 mod Q plus so on. Then nth will be K, Q1, Qn. Then Rn1 will be R1 minus n Rn, that is tip minus tail. So R1 minus Rn upon R1 minus Rn mod Q. Now we can write in summation form, no need to write in each and every term. So we can just have, or we can write it F1 total will be equals to K, Q1 common, QA you can write R1 minus RA upon R1 minus RA mod Q, and here we can write summation A equals to 2 to n. For example, when I say A equal to 2, then it will be K, Q1, Q2, K, Q1, Q2, R1 minus R2 upon R1 minus R2, this term will be obtained. When you put A equal to 3, then this will become K, Q1, Q3, R1 minus R3 upon R1 minus R3 mod Q. Then if it is n, then it will be K, Q1, Qn, R1 minus Rn upon R1 minus Rn mod Q. So this can be expressed in this form. Now, if we just try to find out the force on Q2, so that time this force F2 will be equals to what? Force on 2 due to 1, then force on 2 due to 3, because of this, then this, then this. That means it will be equal to force on 2 due to N. And writing it in the same manner, we can derive this expression, that is equals to summation K Q2 QA R2 minus RA. You try yourself and just bring this expression R2 minus RA mod Q. Here A equals to 1 to N but not equal to 2. 1 to N but not equal to 2. सेकंड पे फोर्स नहीं लगा था, दो अपने आप पे कैसे फोर्स लगाएगा? दैट कैन नॉट बी देयर. सो नाउ यू कैन राइट F3 डायरेक्टली. सो देन F3 will be equal to G. What will be that? Yes, summation A equals to 1 to N and not equal to 3. Yes, not equal to 3. K Q3 QA R3 minus RA upon, yes, R3 minus RA vector mod Q. Now, in generalized term, what you can write? FB, suppose मैं 13 पे निकालना चाहता हूँ, 14 पे निकालना चाहता हूँ, 50th चार्ज पे निकालना चाहता हूँ, so that is FB equals to, बिल्कुल ठीक, बताएं, summation, yes, A equals to 1 to N but not equal to, yes, B, and here K Q B, very good, and QA, and this will be RB minus RA upon RB minus RA over Q. Now just put B equal to 1, then you will get A equals to 1 to N, F1 will be not equal to B, that means 1 नहीं होगा तो A के बाद क्या होगा? 1 नहीं हो सकता, then it will be 2. A equal to 2 to N, K Q1 QA R1 minus RA on RA R1 minus RA over Q. F2 में क्या होगा? A equals to 1 to N but not equal to 2. And K Q2 QA R2 minus RA upon R2 minus RA mod whole Q. So any term you can derive from this. So this is the superposition principle with respect to the Coulomb's law. That means you can find out any force, net force on any charge due to all other charges surrounding to it. So let us try to find out this question. Find net force on charge A. The question is, here is A having 5 microcoulomb charge. Here is B again having 5 microcoulomb charge. C is having 20 microcoulomb charge and D having 45 microcoulomb charge, and all charges are positive. And the separation between A and B is 100 centimeter. B and C is 100 centimeter and C and D is again 100 centimeter. So according to superposition principle, what will be the force on A? That will be the force on A due to B plus force on A due to C plus force on A due to D, and no more charges there. So net force will be this much. Now this is the vector sum. So unless you find out the directions of these forces, we cannot add them. So if we try to find out the direction of the force FAB, so we have to keep our pen at the location of the charge A and then see whether this B will attract it or repel it. So here B is attracting or repelling? Attracting? Just think. कैसे चार्ज हैं ये दोनों चार्ज कैसे हैं लाइक चार्जेस एंड लाइक चार्जेस रिपेल ऑलवेज सो अट्रैक्शन का कोई क्वेश्चन नहीं आता सो इट विल रिपेल so here how it will repel this way or that way so it will repel it this way so this is the force on A due to B okay now it is fine now FAC कैसे करेंगे again put the pen on A and then see what this and then see what this charge C is going to do. That means whether it is going to attract or it is going to repel. Again the charge is positive again, so it is also going to repel. So the pen is to go this side again. तो ये भी इधर ही जाएगा. So this will be force on A due to C. ये भी क्लियर हो गया. Now similarly we can find the direction of the force on A due to D. Again D is positive, so this force will be also there and that will be called FAD. So all the three charges, all the three forces are in the same direction and according to the vector law of triangle law we have studied that when the vectors are in the same direction then their result, the magnitude of their resultant is always equal to sum of the magnitude of the individual forces. So that will be FAD simply. And the magnitude of the force is given by KQ1 and QA QB upon AB square. R square means the distance between them the square. Then this will be K QA QC upon AC square plus K QA QD upon AD square. इसको एक बार फिर से समझें. अगर वेक्टर्स की डायरेक्शन सेम होती है तो उनका जो मैग्नीट्यूड होता है सम का वो उनके इंडिविजुअल मैग्नीट्यूड्स के सम के बराबर होता है. तो इसका दिस इज द वेक्टर सम एंड दिस विल बी द स्केलर सम. So net magnitude of the A will be equal to sum of the magnitude of this, sum of the magnitude of this plus sum of the magnitude of this. And how to find the magnitude of Coulomb's law ने क्या कहा था कि जो magnitude of the force है that is equal to K Q1 Q2 upon R square where R is the distance between them. तो QA QB A और B के बीच में जो हम करेंगे तो QA QB upon this distance is AB उसका स्क्वायर. Then QA QC upon distance is AC का स्क्वायर. Then next के लिए क्या होगा QA QD upon distance AD का स्क्वायर. अब substituting the value K is 9 into 10 to the power 9, QA is 5 into 10 to the power minus 6, QB is 5 into 10 to the power minus 6 upon AB is 100 centimeter that means 1 meter the square. Plus because it's all SI system and MGS system then it is 9 into 10 to the power 9 QA is again 5 into 10 to the power minus 6 into 20 into 10 to the power minus 6 upon 2 ka square. Then again 9 into 10 to the power 9. What is QD? That is QA is 5 into 10 to the power minus 6 and what is D? That is QD is 45 into 10 to the power minus 6 upon and what is the value of AD? The value of AD is from this to this is 300 centimeter that means 3 meter square. So here you can take common that is 9 into 10 to the power 9 into 5 into 10 to the power minus 6. Even you can take this 5 into 10 to the power minus 6. So here you will get 1. Here you have 4 upon 4. Here you have 5 here and 9 here. So here it is 9 by 9. So you can get, or you get simply 5 5s are 25 and 9 2 to 5. Here it is 10 to the power 9 and here is minus 6 and minus 6 is 36 plus, no, when there is multiplication the powers are added. So minus 6 plus minus 6 will be minus 12 and plus 9 will be minus 3. So 10 raised to power minus 3 into, this is 1 and this is 1. So it will be 3. So that means this will become 3 5 are 15, 3 2 are 6, 7, 3 2 are 6, and there is 10 to the power minus 3. That means it will be 0. This Newton. And where will the direction? The direction is along BA vector. So net force A is 0.675 Newton along BA. So this is your complete answer.